Okay, good morning, everybody. It's a little after 9, so I think we'll get started. My name's Anna Zylik. I'm with ICF. We are the vendor working on behalf of Eversource and Energize Connecticut to bring these Passive House trainings to all of you. So thanks for joining this morning. I'm just going to quickly talk about a couple of things before we start. First off, thanks for joining again. This is our second workshop of our 4-part building science series that we have. If you attended our first workshop last week, then welcome back. And if you're just joining for the first time, then welcome. That's great too. These trainings are at no cost, thanks to Eversource, a proud sponsor of Energize Connecticut. And this training is also in partnership with Connecticut Passive House. So we've been working closely with CTPH as we continue to move forward and schedule future trainings. Just a couple reminders, we do have 2 more of these building science trainings coming up. Next one is in April, Friday, April 9th, and then the final one is Friday, April 16th. So we will have a reminder slide towards the end, so definitely register for those as well. And these trainings are eligible for AIA and FIAS credits. Additionally, with this training that we are doing on behalf of Eversource Connecticut, we are also offering a 50% cost share reimbursement for professionals pursuing either FIAS or FI accreditation trainings. So that includes the cost of the trainings and the exam. And once you become certified, we'll work with you to process that 50% reimbursement. So our email address is down below here on the slide. Feel free to reach out if you do have any questions. We're happy to work with you and any questions you may have. You will receive some follow-up emails after the workshop today that will include a survey. So we do appreciate any feedback that you can provide on your experience participating here today. So with that, I'll pass it over to Mike O'Donnell with Stephen Winter Associates, who will be taking over.
Great, thanks, Anna. Thanks everyone for joining this morning. Just some quick administrative stuff we'll get out of the way, and then I'll do intros and that kind of thing. So just so everyone knows, we do have everyone placed on mute, but if you do have any questions, feel free to put them into the chat, and we'll try to take them at the end of each segment. There's a good amount of material to get through, so we'll try to save the questions for the end of each section. The webinar is being recorded, so if you miss anything or want to go back, we'll have a link so you can rewatch it. And also, we do use a polling system for a couple questions throughout the presentation, so we just ask that people get that set up either on pollev.com, the website, or you can do it via a text message. So just have this kind of ready, so when we ask some of the polls, you can respond to the questions. All right, so as Anna sort of mentioned, today's workshop 2 of a 4-part series, focusing mostly on building envelope items. A little bit about me. I'm Mike O'Donnell. I'm with Stephen Winter Associates. I've been with the company 9 years now. My background is in energy management and started off on smaller single-family homes, learning building science. And currently now at Stephen Winter, working on a lot of our passive house projects, doing a lot of the field inspections and construction administration and testing on site. So seeing what's actually going on and getting built in real life, so to speak. And also on the line is Joanna from our office. She'll be on the line behind the scenes. Hopefully there's no technical issues, but if there are, she'll help out. And Julie helping with some of the questions as well at the end of each section. So just a quick blurb about Stephen Winter. We offer energy efficiency consulting, green building certifications, accessibility consulting, 4 offices now, with our newest office in Boston, but also offices in Connecticut, New York, and DC. This is at the end. If you need credits or copies of the presentation, all that stuff, just let us know and we'll kind of direct you in the right direction. So these are our sort of overall learning objectives, really again focusing on the building envelope and how some of these items actually get implemented or installed on projects. And a little bit more granular is we'll look at passive house basics very quickly. You know, it's hard to gauge who knows what about passive house, so we kind of just cover the basics very quick. And then we're going to look at some wood framed construction details and take our first break. So each section will be about an hour, and then we'll have a break at the end of each section. So our first poll question, we're asking, what is your profession? So it looks like we have some responses already. Give that another couple seconds maybe to steady out. All right, so just to keep moving, looks like a good amount of architects, followed by construction managers and contractors, also some engineers, owners, and consultants. So it's a good mix of views, I guess, so to speak, on the implementation side. And just we're asking, what's the one thing that you're hoping to learn about today? Just, you know, kind of focus the presentation a little bit or make sure we're covering all of the topics that people are interested in. Detailing, yeah. Best practices, field installation, window details, always fun. Insulation. Quality control, I see as well. Okay, so yeah, I think a lot of these will be covered. Some of them may also be covered in the last workshop QA/QC for making sure a lot of this stuff gets built correctly, but we'll definitely cover some of this other stuff as well today. So just a sort of recap generally why we're here. In general, we're seeing more and more projects interested in passive house. As mentioned earlier, there are incentives available for the accreditation trainings, and some of the benefits I think we'll look at in a couple of upcoming slides. So we'll kind of hold off on those for now. And also, as mentioned, this is a 4-part series. So today we're focusing really on a deeper dive into the building envelope, with the upcoming being the HVAC and plumbing, and then QA/QC is the last workshop. So passive house basics, this section I'll go through pretty quickly. You know, I'm hoping that people listening know what passive house is, but if not, we'll kind of just go through it very quickly. It's a building standard. It's currently the most rigorous energy efficiency certification that's out there. It's performance-based, meaning you're given sort of energy budgets and targets, and you're sort of free to design within those to be meeting those budgets. The attention to insulation continuity and reduction of thermal bridges is going to be probably a big part of today's conversation, and then emphasis on balanced ventilation will be covered in workshop 3. So some of the goals, you're going to have a more durable building. You're obviously reducing your energy costs. You're going to have better thermal comfort, better indoor air quality, especially using energy recovery ventilation, and the larger overall goal, right, of carbon emission reductions. So some of the principles of passive house: thermal insulation continuity. We want our insulation essentially to wrap around the entire building. Thermal bridge free construction is minimizing where we have weak spots in our insulation. We'll look at some examples. Air tightness is a big one, which is the blower door testing that you need to do, and also the ventilation as mentioned. And so the term passive house makes it seem like it's maybe for a small house, but it can be applied to all different project types, from single family homes to townhouses to some of these larger mid and high rise projects that are also pursuing passive house as well. The air tightness, so this is the blower door, which we'll look at I think more so in the QA/QC section, but this is how you're measuring the air tightness of your project. And a energy recovery ventilation, so you're pulling in outside air, crossing paths with stale air that's being pulled from kitchens and baths. Again, this is more covered in the going to be covered more in the next workshop. So any questions there, Joe?
No questions on technical things. Someone was asking about the polls. When we get to the poll slides, there is instructions at the top, and you can go to a website or text your response in.
Okay, thanks. All right, so like Joe just mentioned, here's the instructions if you missed it from before of how to respond to our polls. And trying to gauge the construction types. Last time it was, I think, 70% wood, 30% steel. So maybe try to gauge if it's a similar mix this time. All right, so that seems fairly steady at the moment, but 64 on wood, so that's good because the majority of the presentation is going to focus on wood, but we also will touch on steel studs and not too much of the other construction types. We do see those used, but I think once you go outside of New York City, it really does become wood dominated in terms of construction types. All right, so we're going to just spend some time looking at the various wood framed wall types that are out there, or ways to build with wood, and kind of talk about each of them. And then, the second part will be diving into what we're actually seeing being used, and also, we have a lot of videos of hands-on application of how these systems are being implemented. So, as mentioned, right, wood is the most common building material for low to mid-rise that we're seeing out there. And you can achieve passive house using wood frame. There are some different systems out there, which we'll look at each of these in a little bit more detail and go through them. And I think really what, at least a lot of what we're still seeing, is a lot of the zip system. So we'll keep that in mind as well. I think a lot of us hopefully are familiar with the perfect wall concept that's from Building Science Corp, where you have your sort of sheathing layer, your air barrier layer, and your insulation on the outside, and then you could also have some maybe in between studs as well. That's for sort of traditionally framed wall, but we'll look at some of these other ones just so you can understand what's out there, but then kind of see which one really gets used more dominantly. So this is Larson Truss. It's essentially an additional piece that gets added on the outside. And, this is probably best suited for retrofit application. If you have a, typically framed wall, there's really not much depth here to get too much insulation in those stud cavities. So this allows you to really get a lot more space, right, to sort of super insulate your walls. And then you add your plywood and house wrap or air barrier on the outside and the cladding. So this is a wall type. It exists. We haven't seen it too much, but projects that I have seen that do use it, it's probably going to be on a retrofit or smaller scale type of project. The double stud wall, it also is intended to give you more space to put more insulation, right? We have seen this in theory, I guess, but that some of the drawbacks are, now you're paying for almost double in terms of lumber, and as if you're keeping an eye on wood prices, they've been through the roof lately. You also do have some thicker rough openings that you got to deal with, from an architectural standpoint. So again, this is one that's out there, but not commonly seen, at least on projects that we've been involved with. Prefab and structurally insulated panels, these are a little bit more common. There are different types of prefab walls. You know, there's one system is called Build Smart. They do a pretty good job of prefab system. You've also seen, you know, traditionally framed walls with zip as a panel system. So panelized definitely helps if it's possible or doable within the project budget. But you still have to deal with the panel to panel joints on site. So it's not totally foolproof, but at least each panel should be pretty well put together. It's, you know, being assembled in the factory, controlled environment. You know, it depends what air barrier types of systems you're using, but if, you know, assuming a zip, you know, you can do all the taping and not have dusty surfaces or wet surfaces or all the kind of problems that come with construction sites. So if possible, prefab is helpful, but again, you still have where those panels come together. There are also structurally insulated panels. So this is insulation in the middle. And then you have the OSB sort of fused to both sides. This definitely helps mitigate thermal bridging in that the insulation is already part of the panel. And I think we've seen one or two projects maybe go this route. It's not as common, but it's not that we haven't seen it ever. And another sort of getting more closer to traditionally framed, but we have advanced framing. So this is using studs that are spaced further apart. So you're reducing the amount of thermal bridging through the wood and allowing for wider spans for insulation. So this is more common, I guess, than some of the previous ones. You know, it depends on the project, but you'd probably have about 4 inches on the outside of insulation. You'd also have cavity insulation as well between the studs. And that's, you know, again, depending on the project and what your other systems are, that's probably going to get you to the passive house level of insulation on the walls. So just a little bit more on the advanced framing, right? It reduces the amount of lumber and optimizes the materials used. So you are reducing thermal bridging through all of that wood. So this is just showing all of these separate areas where you can reduce framing from typical framing. So showing that, you know, single top plate, eliminating a jack stud, no header here in a non-bearing wall, single stud at rough opening. So it's really optimizing the framing plan and layout to reduce the amount of wood, and then at the same time also by doing that you're allowing for more continuous insulation, both mostly within the cavity, but you're also going to have probably continuous exterior insulation as well. All right, so with all of that, you know, there's the different systems, so to speak, to choose from. We're seeing more common, you know, 2x6, 2x4 construction framing, but, you know, sort of regardless of what system you've chosen, a lot of it also does come down to geometry and challenging details. So, you know, this is sort of a classic photo, I think, but all of these different connections and slopes and roofs, they all just make detailing the air barrier, I think, that much more difficult. So, we have a couple of renderings from our projects. These little sort of roof bump outs here and here, some little dormers. This one, another sort of roof here. And so, the questions become to be, well, where is the air barrier? Which line does it follow? What line does the insulation follow? Is this going to be included with the envelope, or is this going to be excluded? Is this space being used for anything? Is it sort of storing mechanical equipment, or is it sort of a dead space? And it becomes a balance. We don't want to make just square boxes that have no features at all. But the more items that you keep adding and bumping out, it just gets a little bit more tricky in terms of detailing and how you're going to continue the air barrier around these sort of areas of tricky geometry. So with that, start looking at some detail photos and details in the next slide. So, from below grade to above grade, we have typically your transition from concrete to your exterior sheathing. Again, we're going to probably show a lot of zip. And, they're using a liquid flash to seal that seam, which is pretty good. Down here, they're probably going to have waterproofing that should be extending up and insulation wrapping over and around. And then I think this is zip R, so they have some R value in the sheathing already. So that's one of the critical sort of junctures, is the below grade to above grade transition. You can see that this would be a pretty significant air leak if this wasn't effectively sealed. So kind of moving up the wall, we have, you can have some porches, right? Those are kind of tricky areas that have to get attached back, or awnings. So you can see that here they're using or showing spray foam to help with this continuity, and then also showing the red line of the air barrier and how it's going to connect down. Sometimes these framing members pass through the sheathing or air barrier layers, so you'd have to detail around those to get them air sealed. Or a different approach is, we're going to look at in the next few slides, is doing all of this air barrier and stuff first and then attaching things after. That'll kind of make sense in a second in the next slide. Or like here, we have the air barrier on the wall, the insulation coming down, and then this awning is sort of attached after the fact. So this is I think this is from Zip, and it shows that the sheathing is on first, all of your taping is done underneath, then you're adding whatever it is that you are adding that's going to be kind of jutting out. So in this case, it's a porch, and then doing some additional taping and flashing here to really protect the wood. But the main air barrier stuff is finished and done underneath before any of this gets attached. So this is sort of showing this similar in that this is being attached after. Another area that's sort of tricky is our headers. So they're pretty prevalent thermal bridge and wood frames. So normally it's just wood that's all sort of stacked up here, and that's obviously a spot where you can't get insulation. So there's different strategies, but this is showing that the there's a space left to be insulated. So here they're showing spray foam. We've seen insulation, rigid insulation in there as well. Or you can get prefabricated insulated headers. That would be another option. So this is something that, again, just needs to be detailed and shown, and obviously verified during installation. But this is a little area that can get easily missed, or it could be shown, but maybe the contractor's not used to something like this, so you have to kind of keep some eyes on it to make sure it's actually getting done properly. So this is another example of that insulated header. They have the insulation in the middle. And also it depends on your window detailing and your install, but you may also need some thermal breaks or insulation at the sill as well. So this particular project is calling out a polyiso block that the window is going to be sitting on. You have a little bit of insulation here that's helping to keep the edge of the frame warm. You have some foam in here as well. So we try to keep it simple, but sometimes these window details can get fairly tricky in the amount of insulation you need to keep this spot from being a thermal bridge. So there is a lot of thought that goes into these, at least on the designer side and working with the architect. But you can get details that get a little bit tricky, like this one that has all of these extra layers. And so, this is all great, but the main thing is actually seeing it installed, and can all of this be achieved? So, what's the sequencing? How is all of this going to come together? Is sort of gets worked out in the mock-up phase. The drawing can be great, and it should be thought through of constructability, but when it comes to actually putting it together, that's why we push for mock-ups, which we mentioned a lot in the last presentation, and also we'll probably talk about it more throughout this presentation as well, but trying to actually see if this can be easily constructed, or if maybe the contractor has some ways that there's different strategies that could be used to sort of achieve the same thing. This is from a different project that they were using the sheet membrane on the entire wall, so a little bit different than the zip system, and it depends if you're using a flange window or not, what the window manufacturer says on what you can and can't seal. But this particular one, they're doing the membrane right to the window and sort of sealing it. So this is a little bit simpler of a detail as compared to the other one where you have a thermal block and extra insulation and all that stuff. So try to keep the details simple, but it can be a little bit difficult, again, with trying to mitigate a lot of this thermal bridging. So I might have shown this one on the last presentation as well, but we have, these are the details from the window shop drawings showing how the window is supposed to be installed. And the issues here were there's a lot of little pieces of insulation that are shown that due to sort of construction tolerances couldn't really be met. So some of these might have been a little bit thinner, or not a rigid insulation board. Maybe they were able to fit some mineral wool in there. this I think might have gotten reduced in size because of the sill height and how the window was sitting in the rough opening. Also, the position of this window made it pretty difficult to seal against it. A lot of the passive house windows aren't flanged, so it makes the window alignment, the position of the window is, pretty important because it's sticking further out and not in direct, in this case, direct plane with the wall and the air barrier layer, that you're now, it turned into trying to tape from the side of the window and curl it back, which wasn't really working. So then they added these sort of plastic pieces to make it a flanged window almost. So there's a lot that potentially could go wrong, but hopefully it doesn't if a lot of it is talked about early or caught in shop drawings or performed at the mock-up. And we had some struggles on this project. There was obviously the schedule always is dictating, so the mock-up window sort of was already in, and then insulation and framing was going up already around it before we had a real chance to see what was going on. So we did our tests, of the window to see how well it was performing as installed, and we're seeing fog come out in a lot of locations. It was pretty leaky. And then, because of that, we had them ask them to remove the what has been installed around it to see, how is this taping being done? What are the connections and all that? So this kind of goes back to, getting everything in the drawings as best as possible, but also the sort of critical importance of testing the first window in the mock-up to make sure it's actually working. Okay, sort of jumping around a little bit, but this is similar to that concept before of adding things after the air barrier layer is installed. So this was sort of the original detail where, the air barrier on the wall is shown coming up here. You have your roof. You have some, I'm pretty sure this is foam, but it's like really unclear how, and this wall is really connecting or, making a continuous line with the roof. So what they showed, after discussions, they said, do all of this. Again, this is it first. Do the liquid seal between the zip and the roof, and then add this this piece later on. So that's again back to this concept of do the all the air barrier stuff first, and then any of these tricky architectural features or bump outs or whatever you want to add, kind of add them later. So this is, I think, a similar concept where it was not really clear how all this was going to come together. And, there was discussions and, feedback, I think, from the contractor too, that this was going to be easier. So you can see install overhang after air sealing has been installed. So you're not missing these sort of difficult, critical corners that are very hard to get into and actually air seal. Similar concepts where, again, we're doing all of that air sealing first. And another point on this is you do need the, obviously need the structural engineer on board with this. they need to show how this is actually going to happen structurally, right? So these are actually pulled, yeah, I'm pretty sure these are pulled from the structural drawings, and they're showing how this is going to be achieved in terms of what pieces need to be added to be able to add these sections separately. Just a couple more here. So we have, our insulation coming up the wall. We have the insulation in the roof, and we have our air barrier wrapping around to the ceiling plane. And so sort of these areas are, pretty critical for getting air sealing installed properly. I think this is the same one, just at a band joist area. But, it's really these kind of critical details that get described or called out and shown clearly sort of what the intent is of how this is going to be all sort of tied together. It's really these sorts of areas that are the most tricky, right? Like your regular wall, should be pretty straightforward, should be fairly uninterrupted, but really the foundation stuff and the roof stuff is where a lot of this detailing really needs to be clear and kind of shown with, how it needs to be properly air sealed. So sort of continuing up the wall, we have, it depends on what system you have. This is a flat roof example. So we have our air barrier coming up and over a parapet and then coming down and tying in with a roofing membrane. So you can see how you're making that continuous transition around. And, they're showing this filled with foam to help with some of the air sealing, but also insulation in this location as well to reduce thermal bridging through the parapet itself. A couple more sort of tricky areas. We have our rim joists and band joists. So again, these are all areas that can be fairly leaky from not being sealed properly. So in this particular project, their approach was to spray foam this whole area, so you're sealing it as long as the foam is continuous, but also getting the insulation value there. Here they're calling out all of the different sealant locations, which can be done. It's obviously a little bit more tedious, and you have to make sure it's actually being done properly, but it is another approach in that these areas are at least getting called out. I mean, I think the colors help a little bit in that you can sort of at least draw some attention to these locations to know that these are pretty important areas. Obviously, the red line is our air barrier going up the wall, but these are other, sort of potential weak points that can get missed easily, and then later they're pretty difficult to go back and address when you're doing the blower door test. If everything's sheetrocked, these areas, unless you're now taking sheetrock off to get to them, they can be pretty well buried in the wall that you're not going to easily get to them. Another sort of concept that's out there is this raised heel truss. So it's allowing for insulation to be more continuous if you're using, if the floor of the attic is being used as the insulation location and not the slope. So you can see on a sort of traditional framed, you're kind of getting squeezed and not getting full insulation out here. Whereas with this design, you are allowed, it's raising it up so you have greater dimension here for insulation, especially over that outside top plate there. attic access, so insulating that opening, or having a door that has insulation. There's different ways to do that, but it could be a bunch of insulation boards kind of glued together, or what have you. But it's important to sort of keep that insulation as thick or as continuous as the surrounding areas, and then making sure that is sealing tight. So if, again, this is your air barrier layer, you don't want to have a leaky attic access, either stairs or hatch, that is going to be, a weak spot in your air barrier. So things like that also need to get detailed and shown, what has to happen, as that is something that's penetrating your air barrier layer. If again, the floor of the attic is the air barrier location. And so a little bit more on mock-ups. It's sort of the extent, it depends on the project, but we had one recently that they were showing an outside corner, an inside corner, a window. They had the roof shown as well. You can kind of simulate the foundation to above grade wall connection, and this is all the sort of project specific details and the components that they're going to be using and the trades that are going to be building it. So they went as far as making a little 3D model of what this mock-up was going to look like. They had all the framing sort of picked out, and had the roof opening, and they had, the roof isn't shown here, but they did have the roof installed. They had all of the, again, this was a zip, so they had all the zip taping completed. They had the window roof opening treated and the window installed. So not to say that every project is going to go to this level of detail. The simple way is to just do it as the first window that's installed on the project, on the building itself, as like sort of the bare minimum. But a lot of projects do a sort of standalone mock-up on the side, so everyone can review it and look at it and kind of be on the same page beforehand, before it really gets kind of moving on the project. So the more, I think, details and things that you can show in the mock-up, the better. But you sort of need to balance that with, how much is really allocated for a mock-up. I mean, this is a little bit extensive, right? You have all the framing, you have the roof, you have the window. So it kind of depends on the project and what they're, able to accomplish. But, I think the more you can install, the better. All right, so it kind of takes us through the first section, looking at a lot of wood frame details, and we'll have some questions if any have come in, Joe.
Yeah, we've got a lot of questions, but I'm gonna start off with one that was really it's a good theme to kick off. So on the quality control side, is the superintendent the Passive House champion, or is that another person on site monitoring everything?
Well, so it's actually a little bit of everyone's responsibility. So, if you're working with, say, an energy consultant like us, we would be on site, but we're not there every day, so we can't see every aspect of the building. The architect is there usually more frequently, typically, if they're doing the construction administration. So they're also keeping an eye on, everything, but also, focusing on Passive House implementation as well. But No, it really does kind of come down to the contractor and their own internal quality control. They're obviously there every day. It's their project and they're building it. So what we usually see is that there's someone on the team that, they have their normal responsibilities, but they're also the one that's, checking the air barrier every day or, keeping on track of the, passive house items on the project. So we do think it takes a dedicated person on the construction team. It's not their only job, but it's part of their, role and really keeping an eye on their subcontractors to make sure a lot of the stuff is getting installed properly. So you have those sort of layers. You have a contractor there that's every day that's keeping an eye on it. You have the architect that's keeping an eye on it, and then you have probably an energy consultant that's doing progress visits that's also sort of keeping an eye on it. So it's a lot of eyes on these details, but with varying levels of involvement.
All right. Another question, a more specific one. How do you support the Larson truss?
So I think those get attached back to the existing studs. So you'd have to obviously know where those are to attach them. But you're probably doing that on a retrofit project. And if you are, you're probably tearing a lot of stuff off, the siding's coming off, the sheathing, all that. So you would be able to see those locations and then know where to anchor those back to.
And this was, I think, more of a comment followed by a question. A double stud wall seems like more wood than a Larson truss. Is it? I don't know if you can quantify that, Mike.
Yeah, probably. I mean, you're essentially buying double the amount of wood. So yeah, again, we kind of are showing those to show you that they're out there, but honestly, at least from what we've seen, they're not common use in practice. But yeah, I haven't done the math to know the exact amount of lumber for each system, but I would probably guess the double stud seems more excessive.
Is there a specific type of wood required for advanced framing?
No, you're just using larger. So you're using 2x6s at a minimum. And there's a lot of guides out there that are available pretty freely. You can just search for advanced framing. And, they kind of have a lot of very good details on, the sizes and the spacing and, where you need support or where you don't need support based on, like where you think you would need a support in a 2x4 wall, around windows, you may not need the same thing in a 2x6. So I wouldn't say anything special. I would just say be aware of the details and know that there are some pretty good resources out there that, have all that stuff pretty well laid out.
Mike, kind of combining a couple of questions. Flanged windows. Do you see a lot of them on passive house buildings? And then secondly, if you do see them on a job site, how is watershed? I think that was around slide 35 if you wanted to have a visual.
I think this one maybe. So we don't see very many, honestly. I think this project was able to use them, but a lot of the passive house windows are not flanged windows. So if that's the case, you're sort of dealing with this situation where the window, the frame is the frame, right? It's just here. There's no extra flange coming out that makes the ceiling to the sheathing that easy. So really what becomes the easiest is aligning the window with the sheathing layer or the air barrier layer, and then you're doing the sealant at that joint, and it's all in a straight plane. I think we have some examples upcoming when we show our videos of our installation, but that's really the easiest in that you have all of this stuff in a straight line. With this particular project, you can see that it was bumped out, so this is why this was such a hard detail to get sealed properly. So, you know, if the window was pushed back and this frame was right here, then you could have your air barrier, your baccarat and caulk, and then you can transition to the window.
That actually leads to the next more comment is window details seem more, difficult to accomplish in the field. Are there simpler details, and what's your best advice for that approach, Mike?
Yeah, I mean, there are some, you know, if you're working with a manufacturer like, say, Sega, who provides the tape, they probably can provide some pretty good details. You know, some of the larger window manufacturers have, you know, some can be helpful, but it's sort of, at least from what I've seen right now, a little bit all over the place. There's not one standard like, hey, this is the detail and go do it everywhere. So yeah, it is a little bit all over the map, but I think the best, again, advice that I can say from an air sealing perspective is try to have the window as best you can aligned with this layer here. You know, you might have to do some of this extra insulation around and that, but that shouldn't be too hard to accommodate as long as your window is aligned with this layer, and you can get your air sealing done there, you know, much more easy than having it stick out and you have all this extra crazy geometry to try to deal with.
And you'd mentioned prefab window headers, and are there some manufacturers that like have tried simplifying this process by making products like this?
Yeah, I know they do make it. I don't know the names offhand, but I know it is out there. Most projects that we've seen are choosing to just install it themselves and not buy them. But I know they are available.
In your opinion, is it better to insulate roof rafters or the attic floor?
It sort of depends. I mean, if you have a bunch of mechanical equipment up there, or if your ERV's up there, or ductwork running through there, it's probably better to do the slope. If it's also, you know, you can probably maybe offer that as storage space for, say, like a townhouse type project. But otherwise, if there's nothing really important up there and you can just load the attic floor with insulation, that's probably going to be the approach in those cases. So it kind of depends on what's up there and if you need the space or not for mechanicals and storage.
And I've got two more, and then I think I'll let you kind of continue. So do you have any comments on regular stud walls with cross horizontal battens to add to wall thickness and reduce thermal bridging, such as 2x4 studs with 2-inch battens, and all penetrations are 2x6?
That's a pretty specific question. I would say, A, I'd probably have to look at it, but B, you know, as long as you're achieving your insulation levels that you need, there's no real, you know, no, you can't do that type of thing, right? So as long as you're achieving your cavity insulation and your exterior insulation values that you need to achieve, I don't see a necessarily downside, but sorry, that's super specific. I would want to see a detail before I say anything further about that.
Okay, and the last one for now, and I know I'm not getting through all of them, so we'll try to see what can be answered throughout the rest. If the air barrier is continuous along the perimeter of the exterior, is a bead of caulk a duplication? That if the air barrier is really continuous, then there shouldn't be a need for adding caulk and the costs associated with that.
I guess they're talking about sort of these locations. Yeah, but these areas always seem to leak, and this is, in theory, you're getting your air barrier all perfect along here, but it doesn't always happen. Like, again, it depends what you're using, but if it's, I'll pick on zip a little bit. If it's zip and you're using the tape, is all of that tape 100% perfect? Probably not. So, it's sort of like, yes, in theory, but in practice, these areas just tend to leak, that to the point where, it's called out from the beginning that they need to be sealed. All right, I think we need to stop there, Joe. We're gonna get behind. All right, so we'll take our first break here, come back in 10 minutes and then keep going. All right, so we'll keep moving here. So we have now a good amount of videos to show where we're actually demonstrating and showing hands-on installation of mostly air barriers and then some insulation as well. And this is focusing on wood frame. We also do have steel stud as well. And given our current situation, this was intended to be done on construction sites and show some details, but given that have been mostly locked down, we decided to show these sort of smaller scale replica projects in one of our coworkers' basements, which he was thrilled about, I'm sure. So this is an overview of our zip system little house, so to speak. So we have a foundation to wall connection. We have a window opening. We have one side that has an overhang and another side that shows, if you were doing that strategy of doing the taping first and then adding any overhang or features after to show that concept. And we had a space, a little door and a space to get in there to run a blower door test to see how leaky we are when we start. And then after we're doing all of our air barrier and sealing, a test at the end to see how airtight we can get our little passive house hut here. So the initial blower door test was, nothing taped at all. Just kind of the rough, zip put up there, the window roughed in place, but not really sealed at all. No sealing at the foundation or anything like that. And, just a pretty rough number, but something to get it started of, what our baseline was. So off the bat, we're pretty leaky, right? Almost 1,100, 10,000, or sorry, 1,089 CFM. Pretty leaky, right, for such a small little building. So we just did that to show how, what we were starting from, and then to see after we've done all our air sealing, what we could get the number down to. So this is the foundation detail, kind of similar to the picture that we showed earlier, but here we're using the liquid flash, right? So you kind of gun it out in this serpentine pattern. And then you can come back with the zip has these different spreaders, so you can work with the material in there and make sure you're getting it continuous and sealed, all the way between the foundation and the zip system above. So the liquid flash works pretty well, I think overall, but for scenarios like that, especially that transition to the foundation. And also, I should mention, we are showing zip. We still are seeing it as one of the most commonly used systems. So, with that, we're trying to show the best ways to possibly install and use the zip system. So at the windows, we're using the zip stretch tape, so that allows it to be sort of pulled and worked around, funky corners and tricky geometry. So you start it sort of up the side a little bit and kind of pull it down. So again, that spreader and credit card tool is pretty helpful in that it allows you to really work the tape into, you know, tight corners or other areas, and also lets you push it sort of flat against the surface, so you're making sure you're getting pretty good adhesion. And so you can see he's getting it all pretty tight in the corners, and then it's gonna pull it the corners and stretch it out, as the stretch tape name so is called. So I can fast forward to these a little bit, but just sort of like a final press, making sure it's all flat, it's all installed tight, and you know, fully covering. And then the biggest thing that we see commonly missed is rolling the tape. So that's the specific roller that is available from Zip, and it makes little Z impressions on the tape. So it's an easy way to verify that the tape has actually been rolled. You can use other rollers, but the Z is a pretty good quality control measure, so anyone can go up and look and see if they can see those little Z's in the tape or not. So now he's working up the sides. Again, we're doing the whole thing in the Zip. Or sorry, we did the stretch at the bottom, but we're using the regular at the side. We've seen projects use the stretch all the way around. That's another strategy that can be used. So here again, making sure it's flat against the wall, using the spreader tool to really make sure we're getting the initial adhesion that we need, and then rolling it to make sure it's sticking, because all the tape is pressure sensitive adhesive, so you really sort of do need to roll it to make sure you're getting the adhesion to the surface that it needs to really stick and stay on there. So I think we'll sort of go through this one a little bit quicker, but it's similar to the other ones. You're getting the tape on there, pulling it. Here we use this stretch at the top because it is a little bit easier, and sort of similar process of getting the tape all pulled tight, worked into the corners, and then rolled with the roller. So this is what I was kind of talking about before, with the window being aligned with the air barrier. In this case, it's the Zip system. So you can see, you know, it's essentially baccarat and caulk that's going around. So that gets sort of all gunned out, and then going back with the yeah, these are like it's like a spatula, or actually an icing knife for icing cakes, and you can use that to tool the sealant. You know, a lot of times people like, you know, lick their finger or use some sort of I saw one project, the guy like picked up a stick and was trying to tool it, and that's really not the right way to do it. You should have a specific, you know, icing spatula, is, I guess, for lack of a better term, to really make sure you're having the sealant be smoothed out and adhering to both surfaces. All right, so that was some exterior. This is on the interior. We're showing using tape and air sealing tape instead of baccarat and sealant on this window. So there's different ways to go about it. usually start with the corners and get those in. There's directions from the manufacturer on how to cut the corners and overlap them, so you can get those folds in there pretty tight. And then trying to work in longer strips for the larger runs of the window. So here we have both corners done, and then we have the longer strip that's attaching to the window. It's going over the clips and adhering to the membrane that's wrapping in the roof opening. So maybe skip a little bit. But again, using the tape manufacturer has a little sort of credit card tool too, which is helpful in that you can use it to work the tape and kind of press it tight into corners and sort of roll it or push it flat against the wall. And so we sort of sped it up here and showed the completed installation, but this is an approach for air sealing the windows using a tape instead of a backer rod and caulk. So now jumping back to some of the zip, right? So the traditional tape, right? Making sure that it's flat against the wall. You're not getting any of those fish mouths or areas where it's not sort of fully adhered. Obviously we're in a controlled environment and we're taking our time to do this, but it sort of does need to be that way on the job site too. Going back and rolling it again to make sure you're getting that adhesion from the pressure sensitive tape. So now just doing another joint here, similar to the vertical joint. So this is an outside corner. So usually for these, you would want to use the wider roll of tape. So you can see he's got the wider tape than the sort of typical one that's used at the wall. And sort of speed it up. So we did also want to show the liquid flash, which is instead of the tape, you're using this liquid sealant and then you're smoothing it out. We do think this is probably better, honestly, than the tape, but we've gotten pushback on, I think, the cost of material. So if this is an option, I would try to definitely explore it on your project because it avoids a lot of the issues with the tape in terms of the fish mouths or not adhering or not being rolled or all that kind of stuff, where the liquid really is much, I think, easier to install. You, again, similar to the foundation, you sort of spread it out with the caulking gun, and then you're using the spreaders to make sure you get the full adhesion. and where we think this is like probably the most helpful is especially these sort of tricky areas. You know, if you decided to just build it sort of traditionally, and then now you have to go back and air seal all of these areas, trying to do this with tape is going to be really difficult. So at least, you know, in these locations, the liquid can be much more easily sort of installed around these tough spots. And again, you can get in there with icing spatula tool to kind of smooth it out and make sure you're getting the adhesion that you need. So now this is me trying to tape this location. It definitely took a couple tries to get something that was even usable in terms of video footage. So you'd have to do these corners and make sure that they're sort of really sticking, you know, which is pretty hard to make sure that you're pushing it up. You're working on like this weird angle here. So, you know, making sure that those are fully flat is pretty hard, and then trying to run a piece of tape across here and curl it up and have it hit on the underside of the sheeting is also pretty difficult. You're going to get some like tenting and not totally straight, and you know, is it really adhered? You can see it's like the more you press on it in the middle, the more it sort of separates. So it's a little bit wrinkly and all that. So this is kind of what you'd be up against if you're not sort of thinking about doing the strategy where any of this overhang or stuff would come later, or at least knowing that you should try to be using the liquid, especially around a lot of these sort of, you know, pretty difficult details of geometry to get the sealant in there. So this we have a little pipe penetration. So there's some different gaskets that are out there that are pre-made. You can put those on the wall. It has an adhesive back and it has like a rubber gasket there. And the whatever pipe is going through seals, the rubber seals pretty tightly to the rubber. So they're the pipe seal, the rubber seals to the pipe. So, you know, you hopefully don't have too many penetrations, but if you have, you know, a water line going out to irrigation system, or, you know, any kind of maybe an electrical wire or whatever, these are pretty easy solutions on how to seal those types of penetrations. All right, so this is our sort of final walk around. We have all of our foundation done. We have our window installed. We have our corners sort of wrapped up. We have our pipe penetration sealed. You know, we did a lot of the taping on this side, and then on this last side is where we did the liquid flash at the seams to show those. So I think we do also have the blower door number. I think I'm holding it for a little bit later. So I know people always ask, well, what was your number after? So I think we do have it here. We'll keep you on the edge of your seat. So we also do have a steel stud mock-up that we did. It was pretty similar to the wood one, which we'll show in a little bit, but you know, like we mentioned in the last presentation, you can use steel studs and still get to passive house level of insulation. You're going to need some pretty sizable exterior insulation and obviously insulation between the studs as well. So here we're showing, you know, some steel stud details. So we have 6 inches of mineral wool in the cab between the studs, and then 3-inch exterior with thermally broken attachments. Here we have, again, 6-inch and a little bit thinner of insulation, but you know, in most cases you're filling these studs fully with insulation, especially for steel stud, because it is so conductive. And so I think just touching on some other wall types we didn't do actual mock-ups on, but just showing them. So we have a liquid applied air barrier on an AAC or, you know, CMU type of wall. So this is all the liquid that goes on, and then the liquid at the rough opening. And again, the window here is aligned with at least this air barrier layer, and this gets the backer iron caulk here. So that's an easy connection, and it's not a weird bump out in geometry. The EFIS system is fairly common, so that's where the air barrier goes on the wall first, and then you have your insulation that gets attached with these sort of drainage channels behind it, and then your base and finish layers on top. So in our steel stud video that's upcoming, we're showing a liquid applied air barrier for, say, a metal panel system, and also a liquid applied air barrier that would be used with an EFIS system. And some of what we're calling uncommon tools. So again, this is all with steel stud in mind. I mean, or wood frame, but you know, wood we're assuming most likely is going to be zip. So a little bit different. But we have our wet film thickness gauge. So this is, if you're doing the liquid applied air barrier, the manufacturer tells you how thick it needs to be. So how do you know? You actually have to test it as it's going on and is still wet on the wall. Counter roller, or like Zip has their own roller to really make sure you're getting the adhesion you need on tapes and any sheet membranes. The tape application tool, so there's all different ones. Zip has their spreaders, Sika has their little credit card thing, Proclima has their little credit card thing. These sort of hard pieces of plastic which help you get the tape into certain tight corners and that kind of thing. The plastic taping knives can be helpful for a rough opening liquid air barrier. I think we have that in our video. Putty knife, and really these caulking spatulas. So these are to get that smoothed out continuous bead of sealant that's adhered to the window and the opening. These are pretty important to make sure you're actually getting the adhesion that you need from the caulking. So I think this was in the last presentation as well, but this is showing the liquid applied air barrier and the wet mill gauge going in to check the thickness. So you can check it on the wall to see if you're getting the right size. And then this was a demo from one of the manufacturers, but you're showing these extra tools, the roller or spatula. You know, they have their primer that goes with the membrane. So these are all sort of the accessories you need to be properly installing these products. So for the steel stud and the manufacturers, we did half assuming it was getting like a rain screen and half assuming it was getting EFIS. So again, it's all about reading the manufacturer's directions, right? They're saying the substrate prep, depending on what surfaces it is, how wide of a gap it can span, or if it's a wider gap, how it needs to be treated. The membrane thickness, how thick does it need to go on when it's wet, and are you checking that, right? And then how you deal with different locations, like an inside corner, an outside corner, pipe penetration. So this is all out there from the manufacturer of how these products are supposed to be installed. So that was more for a detailing product at rough openings or different transitions or things like that. Whereas this one is for, the field of the wall. So this is just the roll-on air barrier. So they're saying 2 coats of 30 mils wet and allow it to dry firm between the coats. So, knowing how much you need to install is pretty important to know that you're going to be getting the air tightness that is claimed if you're doing the proper installation. And so these are the from the EFIS side, again, how the surface prep needs to be, how big of a gap you can have, how to treat the seams, and then the coverage and how thick it needs to go on. So with all of that, this is our SketchUp version of the steel stud mock-up. And you can see it's pretty similar to the zip one. We do have a flat roof instead of a sloped roof. We do have our foundation. We have exterior sheathing. All the joints are pretty rough. And, we have our window opening. Speed it up a little bit. Have our blower door fan setup location here. And yeah, so similar to zip, but obviously different in that it's a steel stud construction. So we started with the seams, and this particular product is a liquid applied product. So you first sort of do it in the seam, and then you could do the zigzag pattern as well, but you then take your sort of putty knife and work it down the seam, and that's how you're first doing these seam treatments of the panels. So your exterior sheathing panels are getting sealed first, and then you're coming back with the main air barrier later to coat over the majority of the wall. So on this one, we chose to do the entire rough opening with a liquid applied sealant as compared to like the sheet membrane. So the sheet membranes on steel stud, there's can be a lot of origami and tricky stuff that's going on. So essentially what we're doing is we're going to be coating this entire opening with this liquid applied sealant that is going to protect the entire rough opening. So again, just for a little bit of time, I'll fast forward, but first sealing around any wood blocking, and then, getting it into the corners. here we've done a couple more seams and are starting to do the actual rough opening itself. Again, these serpentine patterns are kind of how the manufacturer shows it being gunned out. And then you, again, keep fast forwarding a little bit. So here he already did the inside of the jam. Now we're doing the sill and sort of up the other side there. And it kind of gets a little bit messy in the process, but then when you sort of smooth everything out and join it all together, it becomes, you can see why it's better, because it's just a one continuous sort of monolithic application to seal these rough openings. So now he's doing this pattern on the outside. And then the last sort of piece of it is we're talking about these sort of spreader knives. They can help you definitely work all of this material around and make sure you're getting the connection between, especially at this corner here, or, where these two surfaces meet. But you can see that, at least from our perspective, this is a much more robust way to seal the rough opening, rather than dealing with, sheet membranes that you have to prime the surface, you have to make sure you have your corners done correctly, you have to make sure it's adhered, whereas this whole process, sort of fully coats the rough opening. So this is after we've installed it using the wet mill gauge. You can see what tooth it hits, and to see if you're getting the actual coverage that you need. So we did a lot of our seams, we did the rough opening, and now this is starting on the actual wall with the sort of traditional liquid applied air barrier. So, just rolling it out, getting the coverage all over the wall, getting the overlap onto the different product that was used at the rough opening. Getting the right thickness that we need, and then letting it dry before doing the second coat to get the thickness that we need, that the manufacturer says you need for it to be, installed at the right density. All right, so that was after the first coat. This is the second coat. You can see some of the sheathing still showing through, but after the second coat, it pretty well covers it. And even obviously after this dries, it's it's pretty just dark blue. You don't really see much of the sheathing underneath show through at all. So that could be another indicator, is if you're still seeing the sheathing show through, that might be, oh, did they do the second wet coat, or did they put it on thick enough? That's another potential way to be able to tell if you're getting the proper coverage. So on the other side of the hut, we're doing the an EFIS system. So there's different ways to do this, but there joint treatment was with a mesh. So this mesh goes on first. And then that, I think I'll skip this one. Then there's a fill that goes over the mesh that seals it. So that's one option, is the mesh and the fill. The other option is similar to the other side. This is just a liquid that's used at the seams, so you don't have to do the mesh. You just use this in similar serpentine pattern, and then use the spreader tools or your putty knife or whatever you want to smooth it out and cover those seams. And this is similar to the other side, but again, a roller liquid applied air barrier that's going on and overlapping those seam treatments that were done, whether it's the mesh or the liquid. All right, so this is our sort of final views after curing. You can't really see any of the sheathing on this one. This one you can maybe see it, but it's not a telltale sign that it's not enough that was used, but it might make you think to ask the question of, how much was applied, and is it 2 layers? What thickness does the manufacturer call out? So this is a little bit pulled from the last presentation, but mock-ups in real life. The project, this particular project, was calling out sort of a half of a wall. They had a door, a window. They had their rain screen. They had all of these sort of components called out to show these different items. And through the project team, and there's another consultant helping out. He's here up on the roof. They decided to build a little hut, so 4 sides and a roof, and they were showing the ethos system, the panel system. This is the rough opening that was sealed, and the windows going in. These are some window attachments that are going on these sort of Armatherm blocks that are covered in the air barrier. Getting the taping figured out of what sizes of tape and the dimensions, and is it all going to fit, kind of stuff. So again, stressing the importance of those mock-ups, and again, this is sort of an all-in approach, right? Like really putting a lot of effort into it, but it does allow the installers to really see how all this is actually going to come together. So, really kind of putting it together first, and then working out any of these last minute details to get figured out before they start, really going full force on the building. And similar, I think I showed this one last time too, but this was, more scaled down mock-up, just a little sort of one wall, one window, but it is showing, probably this is more so for the architects, seeing all the nice colors and the different reveal depths and all that. But we were out there before all of that was done, when it was just the air barrier and the window, so you could see all of those layers before the ethos came in and covered it up. And then you could see it from this side, for the interior side of the caulking and you know, the air barrier that's wrapping in the rough opening. So this is a little bit more of a, I would say, typical mock-up, or not as extensive as the, you know, this kind of sort of dedication. But again, it allows everyone to take a look, make any comments, review things with the installers to get on the same page before the construction really starts flying. So some takeaways from this whole section: follow the manufacturer data sheets, you know, regardless of what construction type or what you know, products you're using. There's going to be some information out there, so it's important to know what they're calling for the installations. If you're not sure, you need help, or you need an extra set of eyes, definitely reach out to the product reps. They're definitely helpful, and a lot of them are willing to make a site visit or two to help, you know, look at something or keep an eye on things. Sure you have the proper tools. So those are those, you know, little things like the credit card spreaders or the roller, or other of those things that might seem minor, or the, you know, the wet mill gauge for liquid applied. Those are all, may seem minor, but they're kind of important to making sure that all these different systems are getting installed the right way. And then ensure someone's checking the air barrier. So again, this kind of goes back to that question, you know, there's different layers, right? So it should be the installer and the installer's sort of foreman that's keeping an eye on it. And then on top of that, you have the GC who's there kind of roaming around, right, and keeping an eye on everything. You also have the architect, and you also have probably a passive house consultant then as well. So there's definitely multiple layers of people checking and keeping an eye on air barriers. All right, so I think we're kind of back on track a little bit for time. Any questions there, Joanna?
Sure. So someone was asking about sealing nail heads.
Yeah, so I think Zip's official official guidance is you don't need to. But you know, our position and take and push is that, you know, we're trying to get to a very tight blower door number, and we need every CFM, honestly, that we can get. So for that, we sort of recommend just using the liquid flash, going over it. You know, you do a dab of it, and then you take one of those credit card things and kind of press it flat, and there you go. You definitely want to do ones where the fasteners were, you know, removed, or, you know, missed and shot through, or something like that. So yeah, there is a little bit of a discrepancy between sort of what Zip says and what we recommend, because we're trying to get to such a tight blower door threshold.
Okay. Another question was, does EVIS require any kind of special inspections? Like, what are you looking for?
Really, the main thing that we're looking for is the air barrier application. So that's the whole liquid applied system, right? The wall is, it depends on what your backup wall is, but is the surface prep, you know, appropriate? And then is the air barrier coverage adequate or sufficient to cover the wall? And then for the insulation, we're checking the insulation board sizes and that it's the right thickness. You know, there's definitely more to EFIS than just that. You know, there's different back wrapping and meshes that need to go with it, and expansion joints, and all this extra stuff that would really more so be an envelope consultant. You know, for what we're looking for is mostly the insulation and air barrier aspects of it. So, you know, if we do see some of those other things, you know, we probably mention it, but you know, that's more of an envelope waterproofing consultant to dive to the next level of those specific types of details.
Okay, and one more. The fluid applied membranes seem rough and hard to get a good finish on top of them. Can you comment on that?
So those you put on the wall, but then they get covered in insulation, and then you have some sort of cladding on top of it. So you're not necessarily putting anything directly on it in terms of that being like a finished surface, or you know, that's going to be exposed to the outside. So it is a layer that's buried behind the wall. And so if it is, you know, it is, you know, not perfectly smooth and flat, which is okay because it's sort of buried in the deeper layers of the wall system.
Do you have time for one more?
Sure.
Okay. On the zip systems, there were a couple that came through, especially asking about if there's a warranty or if other tapes can be used on zip.
I've only ever seen zip used with zip tape. You probably have to ask Zip what they think about other tapes, but I don't know. My gut feeling is that they may not be okay with it, especially because they obviously want to sell you some tape. But yeah, I've only seen Zip used with Zip tape. I haven't seen any other tapes used with it. So that would definitely be a question for Zip to see if they'd be okay with that. I don't think so, but that I would let them answer that.
Okay, and then last one on zip, and it's do you need a weather resist barrier with the zip sheathing?
No, the zip itself has that built in with the green facer that's on it. So really you're just focusing on all of those seams and joints and connections with the tape. So that's why the tape is really critical, not only from an air perspective, but from a water perspective, because it's the tape and that green facer, and that's your weather barrier. So it's pretty important to get the taping done correctly.
All right, I think those were the major themes.
Okay, so we'll take another little break, a little bit shorter, 5 minutes, and then we'll finish up the topics for today. All right, so we'll move into our last section here, focusing on windows, insulation, and some carpentry items. So a little bit of review from the last time, but our passive house windows are a little bit, and not a little bit, better than sort of traditional windows, right? So we're probably going to be having triple pane, double pane at a minimum, but we are seeing more and more triple pane. Spacers are thermally improved to reduce thermal bridging between the panes of glass. Seeing a lot of these tilt and turn windows with the gaskets that seal very well all the way around the window. And like mentioned before, we're seeing most of these without flanges. So that has to be obviously taken into consideration when you're doing your window design details. And so you can see here we have a UPVC window or an aluminum. Those are sort of the two main options that we see being used. You have the, again, the tilt and turn operation, multiple locking points. So when you close these, this does seal pretty well all the way around. And there are also adjustments that can be made by the window installer to the mechanisms themselves on the window to get this to seal tighter or looser. So they can make some adjustments if you're not getting the gaskets to hit as tightly as you need. And they can accommodate different glass packages based on what your project specifically needs. The aluminum one, similar in that it has a pretty robust gasketing system. You can see these sort of big gaskets here. And then to help with the frame, they have extra wedges of insulation and inserts here that you can see are helping improve that thermal performance of the frame itself. And so the install conditions, these kind of vary, but again, for the most part, you're probably going to have to be trying to get some insulation wrapping the frame. This is all sort of analyzed in the design and energy modeling phase, but not always, but you're gonna have some insulation over the frame. Otherwise, you have these sort of weak thermal points in the envelope. So that's why those install conditions and some of the details we were looking at earlier can be a little bit tricky, and that they show a lot of extra little pieces of insulation around. They are there sort of for a reason, but that doesn't make the details any easier. So these are from a CMU project, but they had their gray liquid air barrier wrapping in. They had this green cavity closure piece that is actually fiberglass. So that was good that it was less conductive, obviously, than metal, and that actually terminates on the back here. So you can see that this is all covered in sealant. The window to the rough opening is sealed. The rough opening was protected with the sheet membrane, and that was all sealed. So you can see there's a lot of different layers of sealant, but they are all overlapping and connecting to each other for this sort of continuous application. And then here on the outside, they had it was calling for spray foam between the window and the rough opening, but that was going to be a pain because you can see it's oozing out. So they decided to actually use mineral wool instead. It's easier to get it in there, and then this would get baccarat and caulk around the outside. So a couple words of caution. I think we also mentioned some of this in the last one, but the windows themselves can potentially be leaky, even though you're getting, or you think you're getting good passive house windows. These particular projects, it was sort of unique that the glass installation was done on site. So that's not typically common, but that was an issue that we had to deal with, and making sure that the glass was getting installed properly for the manufacturer. But more commonly is the glass obviously comes in the window when it's delivered to the site, but there's a lot of things that can happen right during construction. So some windows are used as access, to get out on a scaffold or like load materials through or whatever. So those can obviously get the gaskets pretty messed up. There's a lot of dirt and stuff that can get into the gaskets, which obviously impacts how the gaskets seal and when it gets closed. Sometimes windows get broken during construction. A pane of glass gets cracked or something like that. So that's also something to keep in mind and know that those things would need to be obviously fixed before the final whole building blower door test. Also, sometimes the window seals aren't hitting properly. So like I mentioned, there are ways and mechanisms in the window that the window technician can adjust so that it can make those seals tighter. So there are a lot of things to sort of keep an eye on for windows. This particular example was the taping. We were seeing some air movement. We thought maybe it was from the tape. The tape was actually pretty good. It was actually coming through these sort of pieces in the frame. So that was due to the, some of the glass installation on that particular job. But, it's, I guess the main takeaway is just because you've purchased good passive house windows on a project, it doesn't mean you kind of, say, oh, great, and kind of forget about it. You do need to kind of keep an eye on it to make sure they're actually performing as they were advertised, and also, what's shown in their air leakage test data reports. Again, stressing the importance of some of the mock-ups showing the zip tape. Here they use the stretch all the way around. This wasn't the greatest, at least from the caulking perspective. You can see some of the baccarat showing through. You can see that, I think they admitted that they, just ran their finger across the caulk and didn't really use the proper tool. The straps are not fully embedded, so right under here is an area that there could be air leakage at all these straps. Do the straps need to be so big? Can they cut them shorter? Can the window provide shorter straps to them? So these are all sort of the things that were kind of talked about and can be reviewed at a mock-up type of stage. So for this one, the window manufacturer was going to send them the shorter straps, so they didn't have all this extra material. And then also, these were going to get fully coated and embedded in sealant, so you don't have these hairline air leak gaps behind the clips. And, we show them the right tools to be using on, the different caulking spatulas and that kind of thing to really get the proper adhesion. And also, you shouldn't really see any of this baccarad showing through at all. So these are all things that can be sort of discussed and, kind of get on the same page about early rather than later. Some similar examples. Again, the window here, this is an ephes wall and a window, and it is in a mock-up, but you can see the window is aligning with the rough opening and it's going to get sealed there. So again, keeping that straight makes it much easier. This is a CMU project. We have here they use the sheet membrane coming in at the roof opening instead of the liquid, but they did a pretty good job with it. So that came in and got all sealed. Then the window goes in, then this is all sealed. And you can see that they did a lot of caulk around those straps and clips to really make sure that they're fully embedded so you're not getting any air leaks around those attachment points. The zip one, this is the one we talked about. That was a little bit difficult because it wasn't aligned, so you didn't have the flange. And this is probably going to come up more in the QA QC session, but we're doing our testing on the windows, trying it from the inside, trying it from the outside. In this case, I think the outside is probably better in that we're, directly attached to the air barrier. So we're trying to see, can we get a number on how leaky this is in CFM, but also how, where are the leaks coming from? Is it through the window itself? Is it through the window, the rough opening connection? Is it actually coming from maybe any of the zipped tape that isn't, might not be perfectly done. So we do spend a lot of time and focus on windows in terms of testing to make sure that the installation is what it needs to be. These are probably some of the most critical details. The window itself, if that's leaking, or if the rough opening connection is leaking, it's going to be a pretty tough time. Again, when it comes to that whole building final blower door test at the end. A few other, I think I showed these last time as well, but here we're just testing the window before they did any sealing at the roof opening to see, is the window itself pretty airtight or what's going on, and then a couple of days later doing it after they've done the interior taping and the caulking on the outside to see how that is holding up as an overall assembly. So with that, we have a couple more of our videos focusing on windows. So again, the baccarad caulk between these surfaces, sort of getting it all in there and set before you do the caulking, making sure it's not sticking out too far or not recessed in too deep. And then coming back and doing the sealant, and then using the right tools to smooth it and get the connection between the adjacent surface and the window itself. So on the inside, there's different strategies, but a lot of times you do need some sort of insulation between the window frame and the rough opening. Otherwise, this is just sort of like a dead air space. I mean, you are getting probably baccarad caulk on the outside. It offers a little bit of something, but a lot of times we see mineral wool or spray foam or something called out for here from an insulation perspective. So in our little example, we showed that this is all filled with mineral wool to fill that gap between the opening and the window. And sort of depends on the sequence, but how we chose to do it was we did the exterior caulking and background, let that dry, and then you have a backing. So when you're putting this mineral wool in, it's not just falling out the other side when you're putting it in. And so similar to before, but you have the mineral wool in there. You want to make sure that you have to verify that that's in there first. And then you're doing the taping. In this example, we're showing I think tape on half and maybe caulk on the other half. This is similar to the example from earlier about the taping. Usually start in the corners and then run these larger pieces to make sure you're getting over all of the clips. So yeah, I think here I did the 3 sides with tape. And then at the bottom, you have your baccarat in there already. And then just showing going around all of these attachments. And then using the tool to really sort of spread it and make sure that those clips are totally covered. Again, those are potential little air leak spots, and they can add up if you're only running the caulk, sort of clip to clip and picking up on the other side. Those are spots for air leaks. All right, so insulation. This is a CMU wall, but rigid insulation board. This is more probably applicable. That's commonly used. We are seeing more and more mineral wool being used instead of XPS, but this system here is pretty kind of common. You'd have your zip backup wall, you'd have the zip taped everywhere, and then you'd have your exterior insulation, and then your siding, kind of just comes over that with these extra strips of wood. This is a pretty easy, bare bones way to, I guess, go about it. And then also you're going to have batt insulation on the inside as well, in between all the studs. And then it depends on the roof. I think this particular building was a flat roof, so that's different type insulation type system, right, than a sloped roof. They may have, I'm not sure, this might also be from there, that this is the underside of the roof. Maybe they did some foam down there, or they just did all the insulation on top. There's obviously different strategies of how to insulate and what materials to use. Like I was saying, we were seeing more mineral wool used commonly at rain screen, at brick areas. So it is getting used more commonly. With that, it depends on what your wall system is, but also from the manufacturer, the ways to make sure it stays in place on the wall. So they do have some guidance on pin placement, usually one in the middle and one in each corner, a couple of inches in from the corner. to really hold it in place. There's all sort of different options that are potentially out there, and this is, you know, available from the manufacturers of, you know, what options are out there, and you know, the spacing pattern, and what can be used. So for our example, and we've seen used are these impaling pins. So these sort of spikes get put up on the wall, and then the insulation goes through, and then there's these little retaining caps to keep it in place. So this is back from our mock-up. We have one started just to help us out to keep it straight, but you can see that we have the pattern of one in each corner and one in the middle, sort of up the wall. So these get all installed first, and then you have your insulation just kind of slide through it, and you want to obviously make sure you're keeping it tight to the board below, and using those little retaining caps to keep it, you know, adhere to the wall so it's not falling out of place. So that keeps it more secure and tight to the backup wall. And you can see too, we're sort of staggering it. So when you come around the corner, you can have the board on this side pick up, you know, and kind of fit in there. All right. So now picking up on to the other corner, showing, this is sort of showing that, you know, if you do have insulation wrapping over the frame, this is, you know, kind of seeing it an example. There's probably some dimension called out, you know, the insulation must wrap 2 inches or so onto the frame. So just making sure how that, if that's being called out, that it's actually being achieved, and you know, making sure it's actually getting done when the mineral insulation is going in, you know, not stopping short, like say at the caulk joint or whatever. So for interior insulation, you know, a lot of fiberglass bat, but we're sticking with mineral wool here. So, you know, we're making it look really good. You're doing the cutouts around the electrical outlets, the wires, you're notching around those. That should fully fill the cavity. It should not be compressed and pushed in there. This is usually a struggle. A lot of the times the guys doing the bat insulation just take it and shove it in there, and it looks pretty terrible. So that's one of the items that kind of want to work with the installer early on to show that, you know, it's not only just obviously for sound, that's what they may think, or not really sure what it's for, but, you know, it's for the thermal performance. So really sort of showing them that, you know, it needs to be installed the right way, not compressed, not shoved in there. You know, cut around the wires, all that stuff. So, I mean, this is, we think you know, pretty good job. You know, is every job site going to look like this? Questionable, but that's kind of what we're striving for. There's the different grades of insulation, you know, based on quality. So definitely looking for the grade 1, which is basically the best, minimal to very small amount of gaps or sagging or anything like that. So if we are relying on interior mineral wool or any kind of interior insulation, just making it clear that the quality needs to be there for the installation. So a couple other things, mechanical penetrations. So it depends on the project, what you're doing, but if you have individual ventilation units. Your individual ERVs, it gets very tricky on who's responsible for what. The carpenter is framing out the closet, maybe he's making the holes here for the ports, but then the mechanical contractor is making some connection here. The exterior facade guy might be putting an actual hood, the exterior hoods with the duct that is going to connect to here. So there's sort of a lot of coordination that needs to happen if you're using individual in-unit ERVs. So like in this case, there's a closet here, right, that has the ERV, and this is all the ductwork. And it's really a lot in this area of what's happening, right, and who's doing what and who's sort of responsible for what. So with that, this is probably jumping the gun a little bit. We'll definitely talk about this in the next presentation. Just some of the potential struggles with in-unit ERVs. The ERV closets are usually pretty cramped, not a lot of space. Because of that, it's pretty difficult in insulating and air sealing these exterior connection points. Yeah, you also do have these 2 penetrations per apartment and the filter stuff. So we'll touch on that more definitely in the next presentation, but from an air sealing and sort of air barriers perspective, these exterior ports are pretty important to get sealed properly, and it goes back to, again, sort of defining the responsibility of who is dealing with these. Maybe whoever's working on the outside is going to be doing the hoods, right, and kind of caulking around those, but then on the inside, the HVAC contractors are responsible for the connection to the hood that's stubbing through and sealing that and sealing around it. So there's a lot that can go into these locations and just defining on who's responsible for which part of the air sealing. This is more mechanical stuff. So again, with that sort of narrative, this project was having some problems, so we were trying to write out all the steps, from the hood to what happens around the space between the hood that gets installed, what's kind of needed by the mechanical contractor. So this isn't only ventilation, because it is also piercing through the wall, so it is an air sealing item at the same time. So with that, there's definitely a bunch of different strategies that are out there to deal with that. This is from that same liquid applied that we saw at the rough opening for the steel stud. This is showing, if you do have some sort of pipe, how to address it and seal it with that sealant. That might not be the right strategy for the ERV ducts, but it's showing an example of something that's penetrating through an exterior wall. Maybe could potentially be used, but so this is showing penetration with a rough gap. Then they're saying fill it in with foam, shave the foam, and then apply the sealant on the wall and sort of wrap it onto the pipe itself. So again, just thinking about these things that may be penetrating to the outside, you shouldn't have too many. unless you are doing individual ERVs, then you are going to have 2 per apartment. So that is something to keep in mind from the air sealing perspective. All right, and now sort of getting towards the end here, compartmentalization, blower door. So if you're doing a FIAS project, you're going to need to do compartmentalization testing of the dwelling units. So this is testing of apartments in addition to that whole building blower door test that you need to do at the end. So this testing is not only pulling from the exterior wall, but it's also pulling from the neighboring apartments and from the hallway and from above and below. So this is really where the carpentry aspect gets pretty involved in how those areas get framed and boxed out to make each apartment its own little 6-sided box and separate from the other adjacent spaces. And so we have some air sealing guides that are available on our website. You can go and look those up. There's different, based on different construction types. So we have wood, steel, and masonry, and the different approaches and areas to be sealed called out in those guides. And so some of the key concepts are demising walls between apartments are sealed to separate one apartment from the next. I think this is the CME example, but like I said, we do have them for wood and steel stud as well. And so this is really a key component in that the drywall is running all the way to the, in this case, the CMU, and it's getting sealed at these locations. So you're not having that communication of air and a leakage path between apartments. This is required anyway for fire code. We see this usually sealed with the fire stopping caulk. So it's sort of happening already, but we're also looking at it to make sure that it's being done from a compartmentalization and air sealing perspective. That's really kind of one of the first key items to separate some of these apartments out. So then when you have this, you're sort of boxed out on the walls. We're looking at the floor. So a lot of the projects we see are using a self-leveling floor. So that fills mostly to the bottom of the drywall. There's usually a gap. I think they might even have to leave a little bit of a gap, but it closes up most of it. And then the flooring goes in and the base trim, and that gets caulked. So that's helping take care of that bottom, bottom of drywall to floor connection. And then we have the ceiling, the top of the drywall to, we see a lot of concrete plank projects that's sealed at the top. So that's how you're making the connection at the top of the wall to the floor that's above you. And so fire stopping is another component, again, needed for fire code, but we're also taking a look to make sure that it's being done for compartmentalization aspect. So you can see here they have obviously the pipes well spaced out. They have the insulation on it, so it's insulated through the floor. They have the fire stop sealant going all the way around, and then they have their clamps that they're going to put back and to hold the pipes there. But you can see that they've moved them up so they can make sure that they're getting the continuous seal all the way around the pipe that's when the insulation that's penetrating through the floor. Some other areas, so electrical boxes at demising walls, those can be leaky areas, and those are, again, typically sealed for fire reasons, but again, it's important for compartmentalization. If you have any sort of communications panels or electrical panels, that kind of stuff, some of these large gaps can be pretty leaky. Making sure that that's kind of tighter, or when the panel goes on, it gets sealed all the way around to the drywall, and then the panel door needs to close pretty tightly. Any access panels, if you need it, you can put some gasketing on there. It's sort of like if you need to do it, but some are tighter than others. This one looks pretty bad. It's got a big gap. Other ones come, pretty tight from the factory. Piping penetrations, so under sinks and around shower heads, which I think is the next one, that these are all areas that you can get air leakage. So making sure that those are all sealed before doing your compartmentalization blower door testing. Water lines to the toilet or in the shower head. These are all little areas that start to add up if they're left unsealed. Another big one is door frames. So frame to the drywall, this can be pretty leaky, especially on both sides. If it on the inside of the closet, it might get forgotten about, it's the inside of the closet, no one can really see it, whatever. But this can be a fairly leaky location all the way around on both sides of interior doors. Window stools, so where the stool sits and meets the drywall below, underneath there. The gap between the window and the sill, that can be another leaky spot. Like we talked about floors, so the trim to the floor, that can all, this can be a pretty big leak all the way around. So that's also something to keep an eye on. So not calling out a lot of stuff, not maybe every single thing to take a look at, but again, those air sealing guides are pretty good in that they have some good details. They call out a lot of stuff from, from foundation up the wall to the, if you have like a top level apartment, what if there's any special considerations there, and a lot of these more sort of smaller details, but they will add up. So those air sound guides are pretty good and fairly extensive in covering all of the things that could potentially be leaky. And then sort of not necessarily related to compartmentalization, but more so, I guess, carpentry type of thing is when we're getting towards the end of the project and we're ready to do the whole building blower door test, we do need all of the door weather stripping installed, exterior doors, and usually this is something that happens very late in the project or last, so to speak, on the project. So just being aware that this needs to happen sooner rather than later, because all of these are going to be pretty big air leaks for the blower door test. So just sort of making a note of that, hey, all this exterior door weather stripping needs to be installed before we can do that whole building blower door test. It's usually not an issue. It's just making the project team aware of that they push that up in the schedule a little bit. And then also the materials, they should be mechanically fastened, so no peel and stick membranes or gaskets. Those usually fall off and fail pretty easily. And then also at the bottom, a lot of times we see this brush material specified, but the brushes aren't really airtight, so we're looking for a solid rubber gasket that seals pretty well. And these should all be thought about in design and called out in hardware schedules, but sometimes things get overlooked, and we hopefully will catch it during a submittal and note that's the kind of material that we're looking for to get us a good air seal on our doors. You probably don't have too many exterior doors on your projects, but if each one is leaking significantly, that's not going to help that full building blower door test number. So. All right, so some recommendations or do this type of thing. So really understand the window install details and the full install sequence. So like we mentioned, there's not one great, hey, use this detail everywhere. So with that, it does take, diving into that your specific detail a little bit deeper and understanding, oh, we need extra insulation here. We need, insulation over the frame on the outside, all that kind of stuff. And then really looking at and understanding how is that actually going to get built, right? So that goes back to the whole mock-up thing and how, we're actually going to build this thing, and looking at constructability and if there's any last minute changes that are needed. Yeah, like I said, if you need insulation wrapping the frame, making sure that that's not getting overlooked. You need insulation between the rush opening and the window, that's getting installed, like the mineral wool we were showing. If you need any sort of extra wedges of insulation, as you saw in some of the details, keeping that all in mind. The testing of windows, we also emphasize and stress is pretty important. We're checking definitely the first one that goes in, and then periodically checking them throughout to see if the window is performing the way it should, if the connection to the rough opening is appropriate, and really focusing on the windows as a critical sort of component of the airtight layer of the building. And then keeping an eye on insulation grade 1, the best quality of the install. You're not getting areas that are missing or big gaps or compressions, in interior bat, to really keep that thermal insulation continuous and keeping the building well insulated. So with that, we did have some donations for our mock-ups that we built in, again, my colleague's basement. So we definitely mentioned Zip a lot, and we appreciate their donation. They have the different Zip panels, whether it's the regular panel or the Zip R, which has the insulation installed with it. They have their tapes, all the different sizes. They have the Zip liquid flash. They have the sausage gun. They have the spreaders. So there's a whole bunch of components that go into the Zip system. The window was from Star. We see them on a lot of our passive house projects. They're definitely good to work with. They know what kind of we're looking for when we're doing our testing. They know all the adjustments to make if needed. So again, thanks for the window there. Rock wool for the mineral wool insulation, both interior and exterior. Sega for the taping on the inside that we showed. They also make exterior tapes and membranes for the outside and that kind of stuff. And then still for the ethos, air barrier, and Carlisle for the rain screen, the blue. So these are the yellow, and this was the blue. So, I mean, not to say that there's not other manufacturers. There's plenty of other people out there that can provide similar products. These are just ones that we see commonly, and we have pretty good relationships with all of these product reps. All right.
Okay.
Questions
questions
there?
for you. Yeah. So, if you can explain a little bit more about fiberglass windows and like the advantages of those versus other material windows for related to passive house, that would be excellent.
That's a good question. I'm not sure specifically what they're looking for, but most projects are using the UPVC windows. We still do have some that are choosing to use the aluminum. I can't speak to pricing, but I think I would have to imagine they're using UPVC for pricing reasons. There are a lot of affordable projects that are using them, and they are getting the performance that we need. So again, the glass and the selections there are, getting the thermal performance that we need, and then also we are getting the air tightness results we need out of those window systems. So we definitely have seen some with the aluminum. It seems to be there more. I don't want to. Yeah, I'll leave it at, we see more of the UPVC on affordable projects, not to say they're not used on non-affordable projects, they are. But that's the sort of dominant window that we've seen chosen on affordable housing, passive house projects.
Another question, what were blower door results on your mock-ups?
I knew someone was going to ask that. I think it's in the last presentation, probably workshop 4. I didn't have time to look it up, but we were meeting our 0.05 CFM per square foot of enclosure. So it's definitely in the QA/QC. I thought it was in this one. I guess it was not, but it was probably like, I don't know, 4 CFM, 7 CFM, something in that range. I'll have a definite number in workshop 4.
Lots of suspense. Okay.
Yeah.
All right. So what kind of weather stripping do you recommend for any kind of steel exterior door frames?
So yeah, we see different. We see some different brands, but one that comes up a lot, I think, is Pemco, P-E-M-K-O, something like that. And it's the gasket all the way around the door is sort of screwed into the frame, and it has a solid, rubber gasket. So when the door closes, it pushes tight against that. And at the bottom, the sweep is attached to the door, screwed in, and it's a solid piece of rubber that when it closes, it seals tight. So there's, very specific numbers that these manufacturers call out for their products. I don't have those memorized, but I think it's Pemco that is the brand that offers it. I'm sure there's others, but again, it's really the solid material that's mechanically fastened to the frame is what we're looking for.
If anyone has any other questions, you can type them into the question feature.
Okay, and we'll kind of wrap up, I guess, final thoughts and takeaways, any feedback is always welcome. This is the spot we ask for your final thoughts for today. All organized, I try. Great videos. Yeah, we had fun making those. Helpful, thank you. Yeah, hopefully showed some details, as we said, that can be kind of different and all over the place, but trying to at least show some of the things that we've seen and potentially, easier or better ways of doing things. All right. I think we answered most of the questions, hopefully. Here's my contact info if you have any other, burning questions that we didn't get to. Feel free to email, reach out. And like we mentioned at the beginning, there's a couple more workshops upcoming. So there'll be one for the mechanical trades is next. And the last one is the QA/QC. I do promise the blower door numbers are in that one. So. Anything else, Anna, that you want to add, or?
Yeah, just make sure everyone's registered for the next workshop, April 9th, and be on the lookout for our emails with the survey link. We would appreciate any feedback or comments. That's it.
Okay, thanks. I think that's where we'll stop for today. Thanks everyone for joining us.